Chapter 6. Roman Engineering, 27 BCE, 476 CE. Infrastructure as a tool of empire. The Roman Empire's remarkable achievements in engineering and infrastructure played a critical role in its rise to dominance and its long-standing influence over vast territories. From the famous Roman roads that spanned thousands of miles to aqueducts that brought fresh water to cities, Roman engineering was a cornerstone of its military, economic, and political power. These advancements were not only technological marvels, but also tools of control, used to solidify Rome's dominance over its subjects and competitors. The Romans were unparalleled in their ability to build infrastructure that enhanced their ability to project power over long distances, support large populations, and ensure the efficient flow of goods, people, and information across their empire. However, as with many other technology advancements throughout history, access to these technologies was not shared equally. Roman engineering reinforced a social and political order that favored the elite, while often subjugating conquered peoples. This chapter will examine how Roman engineering helped build one of the largest and most powerful empires the world has ever seen, the inequalities it created, and how its influence continues to shape modern society. Roman roads, the arteries of empire. Perhaps the most iconic of Rome's engineering achievements was its vast network of roads, stretching across Europe, North Africa, and the Near East. Roman roads were not merely pathways for travel, but strategic military and economic lifelines that helped hold the empire together. By the height of the empire, the road system covered over 25,000 miles, with 500,000 miles of paved roads, facilitating the movement of legions, goods, and information. The design and construction of Roman roads were highly advanced for the time. Roads were built with multiple layers of materials, including gravel, sand, and stones, which ensured durability and efficient drainage. The roads were crowned in the middle to allow rainwater to run off to the sides, making them usable even during poor weather conditions. The durability of these roads is so impressive that many sections of the Roman road system remain in use to this day. Roads served a primarily military purpose, allowing Roman legions to march quickly to trouble spots anywhere in the empire. This speed and efficiency in movement gave Rome a decisive advantage over its enemies. When rebellions flared up or invasions threatened, the legions could be rapidly deployed along the empire's well-maintained roads, crushing resistance and maintaining order. However, Roman roads were not just for military use. They were also vital to the economy. Merchants used the roads to transport goods between regions, stimulating trade and ensuring that Rome's cities were well supplied. The roads facilitated communication, enabling messengers and couriers to travel quickly across the empire, ensuring that the Roman government could administer its vast territories effectively. But while Roman roads brought undeniable benefits, they also symbolized Roman control and power. The roads connected Rome to its provinces, creating a system where wealth and resources flowed primarily toward the capital, enriching the elites, while often exploiting the conquered peoples. In many regions, local populations were conscripted into forced labor to build and maintain these roads, further highlighting the unequal distribution of benefits that Roman infrastructure often entailed. Aqueducts, bringing water to the people and the elite. Another of Rome's monumental engineering achievements was its system of aqueducts, which brought fresh water to cities and towns across the empire. The Romans built aqueducts to transport water from distant sources, often many miles away, using gravity alone to move the water over long distances. These aqueducts supplied baths, fountains, private households, and, most importantly, the elaborate public baths that became a hallmark of Roman urban life. The most famous of these aqueducts is the Aqua Claudia, completed in 52 CE, which stretched over 40 miles to bring fresh water to the city of Rome. The aqueduct system was a feat of engineering that required precise calculations to maintain the correct slope over long distances, ensuring that water flowed steadily without stagnation or excessive speed. The arches of Roman aqueducts, some of which still stand today, are enduring symbols of Roman ingenuity. Aqueducts played a crucial role in maintaining the health and sanitation of Roman cities, providing a reliable supply of fresh water that supported the empire's growing urban populations. In Rome itself, the aqueducts could supply an estimated 300 million gallons of water per day, far more than what most pre-modern cities could dream of. However, the benefits of these aqueducts were not evenly distributed. While aqueducts provided public water to baths and fountains, access to fresh water was often reserved for the wealthiest citizens, who could afford to have private water supplies piped directly into their homes. The elites enjoyed luxurious baths and private pools, while the lower classes and slaves were often relegated to public baths or less sanitary water sources. Moreover, the construction of aqueducts was often a tool of Roman colonization. In newly conquered territories, the Romans would build aqueducts to supply their own settlers and garrisons, sometimes at the expense of the local population. The arrival of Roman infrastructure signified the imposition of Roman control, with the conquered peoples forced to adapt to the new systems or faced marginalization. Roman architecture, monumental symbols of power. Roman engineering extended beyond roads and aqueducts to monumental architecture, which was as much a tool of political and social control as it was an artistic expression. Roman buildings, particularly temples, forums, baths, and amphitheaters, were designed to impress upon the local population the grandeur and power of the Roman Empire. One of the most iconic examples of Roman architecture is the Colosseum, completed in 80 CE under Emperor Titus. The Colosseum was an immense amphitheater that could hold between 500, 0, and 800, 0 spectators, making it one of the largest arenas ever built. It was used for gladiatory contests, public spectacles, and even mock sea battles. The sheer scale and engineering sophistication of the Colosseum symbolized Rome's power and control over its subjects. Roman temples and public buildings were often constructed using the latest engineering techniques, including the use of concrete, arches, and vaults, which allowed for the creation of larger and more complex structures than ever before. The Pantheon, built by Emperor Hadrian between 118 and 125 CE, is one of the most impressive examples of Roman architectural innovation. Its vast dome, with an oculus at its center, remains one of the largest unreinforced concrete domes in the world. These monumental structures were not just physical symbols of Roman dominance, they also served as tools of political control. By building grand temples, baths, and arenas in newly conquered territories, the Romans aimed to win over local elites and integrate them into the Roman system. These buildings were a reminder of the benefits of Roman rule, but they also reinforced the social and political hierarchy. The elite classes were often given privileged seating in arenas like the Colosseum, while the lower classes and slaves sat in the upper tiers. Moreover, Roman architecture often displaced local traditions and building practices, further asserting Roman cultural and political dominance. In provinces like Gaul, Egypt, and Judea, local architectural styles were subsumed by Roman designs, signaling the imposition of Roman values and the integration of these regions into the empire. The Roman military machine, forts, and siege works. Roman engineering was also central to the success of its military machine, which relied on infrastructure to project power across the vast expanse of the empire. Roman soldiers were not only warriors, but also skilled builders, responsible for constructing the roads, forts, and siege works that allowed the legions to operate efficiently in hostile territories. Roman forts, or castra, were a key component of the empire's military infrastructure. These forts were strategically located along the empire's borders and along key roads, serving as bases for the Roman legions and as symbols of Roman authority in newly conquered regions. Roman engineers designed these forts to be highly efficient and defensible, with standardized layouts that included barracks, granaries, workshops, and defensive walls. One of the most famous examples of Roman military engineering is Hadrian's Wall, built across northern Britain during the reign of Emperor Hadrian 138 CE. Stretching over 70 miles, the wall was constructed to protect the northern frontier of the Roman Empire from the Picts and other hostile tribes. The wall was fortified with watchtowers, forts, and gates, allowing the Roman army to control movement and defend against invasions. Hadrian's Wall was a physical manifestation of Roman power, marking the edge of the empire and separating the civilized Roman world from the barbarian lands beyond. Roman siege works were another testament to the empire's engineering prowess. The Romans were masters of siege warfare, using a variety of tools and machines, such as catapults, ballistae, and battering rams, to breach the walls of enemy fortresses. The Roman army was also adept at constructing temporary fortifications, including trenches, palisades, and siege ramps, which allowed them to lay siege to cities and strongholds for extended periods. The Roman siege of Masada, a Jewish fortress in modern-day Israel, is one of the most famous examples of Roman engineering in military conflict. In 73–74 CE, during the First Jewish-Roman War, Roman legions laid siege to Masada, where a group of Jewish rebels had taken refuge. The Romans built a massive siege ramp, allowing them to bring battering rams and siege towers to the walls of the fortress. After months of siege, the Romans finally breached the walls, though they found that the defenders had committed mass suicide rather than face capture. The siege of Masada remains a symbol of both Roman military might and the lengths to which the empire would go to subdue its enemies. Roman engineering and the unequal distribution of power. While Roman engineering and infrastructure brought immense benefits to the empire's cities and citizens, they also reinforced the unequal distribution of power and resources. The roads, aqueducts, and monumental architecture that defined Roman civilization were often built on the backs of conquered peoples and slaves who labored under harsh conditions to construct these grand projects. The benefits of Roman infrastructure were not shared equally among the empire's population. The elites, both in Rome and in the provinces, enjoyed the most direct access to the fruits of Roman engineering: private baths, homes supplied with fresh water, and seats of power in the amphitheaters and temples. In contrast, the lower classes, including the urban poor and rural peasants, often had limited access to these amenities. In many cases, the construction of Roman infrastructure displaced local populations, particularly in the provinces. The building of roads, forts, and public buildings often required the seizure of land, which was taken from local farmers and given to Roman settlers or elites. This process of displacement reinforced the power of the Roman elite, while marginalizing local populations. The Roman system also relied heavily on forced labor. Slaves, prisoners of war, and local populations conscripted into labor gangs were often responsible for building the empire's infrastructure. These laborers received little benefit from the projects they built, and their contributions were largely erased from the historical record. The roads and aqueducts that brought wealth and prosperity to Rome were built through the exploitation of human labor. A reminder that even the most impressive technological achievements can come at a great human cost. The legacy of Roman engineering. Roman engineering left an indelible mark on the world. Even after the fall of the Western Roman Empire in 476 CE, the infrastructure built by the Romans continued to influence European, Middle Eastern, and North African civilizations for centuries. Many Roman roads, bridges, and aqueducts remained in use well into the medieval period, and the architectural principles developed by the Romans formed the foundation for future innovations in building and construction. The influence of Roman engineering can still be seen today in the modern world. Many modern cities, including London, Paris, and Rome itself, were built on the foundations of Roman infrastructure. The Roman road system, which connected the farthest reaches of the empire, laid the groundwork for the transportation networks that continue to shape Europe's economy and geography. Roman engineering also set a precedent for the use of infrastructure as a tool of political and social control. The idea that roads, aqueducts, and public buildings could be used to project power, integrate diverse populations, and maintain control over vast territories has been emulated by empires throughout history, from the Byzantine Empire to the British Empire. Conclusion. The Roman Empire's mastery of engineering and infrastructure was a key factor in its rise to power and its ability to maintain control over a vast and diverse population. Roman roads, aqueducts, and monumental architecture not only facilitated the movement of armies, goods, and information, but also served as tools of political control and cultural assimilation. However, the benefits of Roman engineering were not shared equally. The infrastructure that sustained the empire was often built by forced labor and benefited the elites at the expense of the lower classes and conquered peoples. Roman engineering reinforced the social and political inequalities that defined the empire, creating a system in which the few reaped the rewards of technological innovation while the many bore its cost. As we look to the future, the lessons of Roman engineering remain relevant. The infrastructure that underpins modern society, roads, bridges, communication networks, and now artificial intelligence, must be built with an eye toward equity and inclusion. If we fail to ensure that the benefits of modern technology are distributed fairly, we risk repeating